Assalamu alaikum and good morning everyone. My name is Mahmoud Rafi. Today I'll be presenting Module 1 Assignment 1 which is Offshore Production Life Cycle. The offshore production life cycle is explained in 5 stages. They are acquisition, exploration, development, then production and abandonment. At the first stage is acquisition. This is a process to obtain permission and legal rights from the government or relevant agency before drilling of exploration well. So there are various ways to acquire this interest, like including direct negotiation, open tender for new licensed acreage held by countries, or by farming into existing licensed blocks where other countries already have interest. So, like international companies like ExxonMobil, Shell, Repsol Oil and Gas, and other international oil companies must enter into a formal arrangement with the Malaysian government in order to lease offshore oil and gas field for future. Production sharing contracts and risk sharing contracts are another method for managing the distribution of oil and gas production field between national oil companies like Petronas and Pertamina and foreign oil companies like BP and Shell. Second stage is exploration. It is the process to search for oil and gas field. And exploration includes searching underground for oil and gas deposits and evaluation in case of discovery. After evaluating the potential for oil and gas field in the licensed block, the drilling location for an exploration well is selected based on the survey data. So among the different types of survey, let's discuss about geosurvey. It is to take the geographical and geophysical data, and it's also to collect data to aid in design, installation and post-installation. And lastly, to map the potential area using seismic sensor and then to be studied by geologists. An illustration of this geosurvey has been shown on the right side of the slide, as you can see. Second type of evaluation is soil sampling. So once the geographical data shows that the area have the potential to be reservoir, then ROV will be used to collect soil and sediment for further confirmation. It has been illustrated on the right side of this slide in these two pictures, as you can see. Thirdly, appraisal well. ROV will be used for bubble monitoring and operation monitoring during appraisal well or drilling. Once the soil profile and condition have confirmed the possibility for oil, appraisal well has been shown in the right side of this slide in this picture. On this stage, development, it is a process to design, construct and install offshore oil and gas production facilities. Development involves the planning and building of oil and gas refining systems, pipelines and storage and offloading facilities, and the digging of producing wells. When building a big gas field, the location is also evaluated for liquefied natural gas growth. Liquefied natural gas project necessitate the construction of large-scale liquefied plant and exporting facilities, as well as the development and management of long-term client partnerships. It may also construct upgrade facilities in extra heavy oil ventures, such as oil sands project to transform the output from low-grade heavy oil to high-grade light oil. The process of assessing an environment project potential influence on the ecosystem is called an environment impact assessment, and they are usually used to evaluate any potential effect as well as to create and evaluate any mitigation or avoidance strategies that might be necessary if the project were to move forward. So, what are the objectives of environment impact assessment? To promote environment-friendly and long-term growth, to render detail on the environment impact, and also to predict and evaluate the ecological, economic, and social effect of growth related activities. And lastly, identification of legitimate option and mitigation measures. In this slide, as you can see, there are two pictures of fixed platform. On the left side is the wellhead platform, and on the right side is central processing platform. On this slide, you can see floating vessel. On the left side is floating production, storage and offloading type, which is in short known as FPSO, and on the right side is floating liquefied natural gas, which is in short known as FLNG. On this slide, subsea production system diagram has been shown on the right side, where subsea production systems include subsea pipeline, subsea control module, a subsea manifold, a remotely operated vehicle, which is in short known as a ROV, and many other components as illustrated on the right side of this slide. Fourth stage is production. It is the process to produce oil and gas from seabed, subsurface to the offshore production facility, which involves drilling production wells. On the diagram below, it has been illustrated from production to transmission to distribution, as you can see. In this diagram, as you can see, the process of extracting the hydrocarbon and separating the mixture of liquid hydrocarbon, gas, water and solid, removing the constituents that are non-sealable, and selling the liquid hydrocarbon and gas. Production sites often handle crude oil from more than one well. Oil is nearly always processed as a refinery. Natural gas may be processed to remove impurities either in the field or at a natural gas processing plant. After the oil and gas reaches the offshore production facility, it will then proceed to further separation of oil, gas and water before exporting to an onshore processing facility for the next step in the oil and gas refining process. For underwater equipment, the use of ROV for inspection, repair and maintenance are widely utilized to enhance data acquisition and observation of the underwater assets such as subsea pipeline, platform jackets, and subsea production system equipment that require frequent inspection due to harsh deepwater environment. One of the top reasons to use an ROV is that it allows exploration of an area that may be too dangerous for a diver due to the pressure of water, temperature, or space. ROV are able to go into almost any place underwater, keeping divers safe. So, in this slide, we will discuss the first category of ROV, which is the micro or known as mini ROV. It is the smallest class often used to inspect hard to reach areas at shallow depth such as pipe systems and submerged infrastructure. Second category of ROV is observation class. An observation class ROV is small in size, used to explore lakes, rivers and coastal water. They are often used to test water safety prior to a diver entering the water during mission and conducting inspection. And it is able to be equipped with sonar and custom sensor. They are versatile vehicles. A picture has been shown of an observation class on the right side. Third category is light work class. A light work class ROV is ideal for moderate to deep depth. This ROV is deployed from ship instead of divers to explore. It can be used during inspection to make repair. Large extensions such as laser scanner or specialized inspection devices and sensors can be added on this. The picture of this light work class has been shown on the right side of this slide, as you can see. The fourth category is work class. Our work class ROV is used for ocean floor exploration and inspections at depth that divers are often unable to reach. They act as a safe alternative to divers and are often used in offshore energy projects and deep archaeological investigations. As you can see, it's so huge on the right side of this slide. Several industries utilize underwater remotely operated vehicles to conduct research, do inspection, and make hard-to-reach repair, saving divers from having to go into unsafe territories. They are excellent tools for not only commercial users but to examine the deepest point in the ocean for educational purposes. A picture has been demonstrated of working ROV in this slide on the right side. And ROV are most commonly used in industries such as an oil and gas energy companies, marine construction, shipping, military and law enforcement, and lastly, underwater research. The last stage is abandonment. In this, an oil or gas well is plugged and abandoned when it reaches the end of its useful life or becomes a dry hole. So, plug and abandon operations start by preparing the well site for abandonment activities. Precautions are taken to ensure the well is safe to work around. The site is assessed to ensure safe access and egress and soil condition and stability control of terrain, presence of plant or animals, potentially hazardous atmosphere near the well, traffic and movement, equipment staging and other hazards at the site. Then, removing and salvaging available wellbore casing, tubular, and other equipment. Tubular are removed through the process of free point back off, stretching, or by simply cutting off the tubulars at the predetermined depth using a chemical cutting, explosives, hydraulic cutting, or pulling methods. Removing stuck tubular above the cut using fishing tools. Tubulars below the cut are left in the wellbore. Then, after removal of free tubular, removing stuck tubular above the cut using fishing tools. Tubulars below the cut are left in wellbore. Then, placing cement plugs in the borehole and testing to prevent migration of fluid between different formations. Plugging is subject to federal and state regulations. Regulations may vary from state to state. And then cutting upper casing below grade and capping the well before the surface is reclaimed to match the surrounding environment. Reclaiming activities are subjected to federal and state environment regulations. Regulations also may vary from state to state. I would like to finish my presentation. Thank you for your kind attention.